Okay, this is section 8.2 on polygons. Definition of a polygon. It is a closed figure with sides that are line segments. The sides of the polygon are line segments. What does that mean? This is a line segment. So when you put several line segments together and close it, that gives you a polygon. It has to be closed and all the sides have to be line segments. The angles of the polygon, every polygon has angles, the interior angles are the angles that are formed inside by the union of two of the line segments. For example, the triangle has 3 angles. What is a regular polygon? It is a polygon with all sides the same. For example, a square is a regular polygon because all sides are the same and all angles are the same. So all sides and all angles have to be the same. All sides and all angles have to be the same, have to be equal. Examples of pictures of polygon, of any polygon. We already talked about the triangle. That is one example. We also have a pentagon, which is a 5-sided polygon. We have the figure that looks like the stop sign, which is an octagon. That's also a polygon. It's a polygon that has 8 sides. And again, all the sides are straight line segments. Okay, so we have different types of polygons here. We're going to start with triangle. Again, this is a 3-sided polygon. We know that. We know that a triangle has 3 sides. And we also know that the sum of the interior angles of a triangle is 180 degrees. This is something that you learned a long time ago, and you probably already or still remember it. Then we have a quadrilateral. Quadrilateral means a 4-sided polygon, and the sum of the sides of a quadrilateral, and this is something that is going to work for all the polygons. You can do it this way so you don't forget. You don't have to forget the number. You can say 4 minus 2, because it's a 4-sided polygon, times 180. 4 minus 2 times 180 is 2 times 180, which is 360 degrees. That's the sum of its angles. Then we have a pentagon, which is a 5-sided polygon. And again, this is 5 sides minus 2 times 180. That's going to give you 540 degrees. The 5-sided polygon has the sum of the angles of the 5-sided polygon is 540 degrees. The hexagon is a 6-sided polygon. And again, you go, the number of sides is 6 minus 2 times 180. That is 720 degrees. Then we have the 7-sided polygon, the heptagon. And that would be 7 minus 5 times 180. That is 900 degrees. You can see that from 180 to 360, you add 180, from 360 to 540 plus 180. So it's going up by 180. Then the octagon is the 8-sided polygon. And again, we do 8 minus 2. I made a mistake here. I meant 7 minus 2, which is 5. I'm sorry about that. 7 minus 2 is 5 times 180 is 900. 8 minus 2, which is 6, times 180 is 1080. And so you always do it the same way. The nonagon is a 9-sided polygon. So you have 9 times 2 times 180. And that's going to be 1,160 degrees. And then the decagon, which is the 10-sided polygon. And this is all the ones that I expect you to know. I expect you to know triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. The decagon is 8 times 180, because it's 10 minus 2 times 180. That would be 1,000. Let me see, I'm adding, this is wrong.
It's 260.
440, 1,440 degrees. I made a mistake on this one. It was 1,260 degrees. We have the sum of the measures of the interior angles of a polygon. The formula goes like this. If the polygon has n sides, the sum of its interior angles equals n minus 2 times 180. N minus 2 times 180. The triangles are classified by the measure of the angles. So if you have a triangle that has, of course, 3 angles, the triangle means 3 angles, and the angles are less than 90 degrees, all 3 of the angles are less than 90 degrees, this is an acute triangle. Acute. Each angle is less than 90 degrees. This triangle, it has, again, 3 angles. One of the angles is greater than 90 degrees, so it is an obtuse triangle. Obtuse triangle, so one angle is greater than 90 degrees. One angle is greater than 90 degrees. And this one right here is a triangle that has one angle that is a right angle. This is a right triangle. Right triangle. One of its angles equals 90 degrees. Then we're going to classify triangles according to their sides. So in this particular case, we have a triangle with 2 sides that are the same and one that is not. So 2 sides are the same. That means isosceles. Isosceles. 2 sides are equal. This one has 3 sides that are equal. This is equilateral. All 3 sides are equal. And finally, we have a triangle with 3 sides that are all different. Not 2 of these sides are equal. So this is different than that one and different than that one. So this is called scaling. All 3 sides are different. Okay. Now, we're going to talk about similar figures. So we have 2 figures. This is an example of 2 figures that are similar. They have the exact same shape. but they don't have the same size. So you can see that this orange triangle is bigger than this one, but they have the exact same shape. The angles are equal, but the sides are not equal. They are proportional to each other. Two figures, different inside, but they have the exact same shape. Their angles are the same. Their corresponding angles are equal. And their sides are proportional. For example, if we go back to this example right here where we have the figure A, B, and C, A, B, C, and we have this smaller figure, E, F, D. And this figure, let's call these 2, 1, and 3. They are, this angle B is equal to angle E in measure. This angle C is congruent, meaning equal in geometry, to this angle F, and this angle A is congruent to this angle D. That means they have the same measurement. And if you look at this, the sides are proportional. This is 1 to 2 as 3 is to 6 as 2 is to 4. So these two figures are similar because they have the same angles, the same measurement in their interior angles, and the sides are proportional. Congruent figures are two figures that are the same shape and the same side. Two figures that are the same shape and the same size, not side, and the same size. Now we can talk about quadrilaterals. They are polygons that have 4 sides. This right here is a quadrilateral. These two sides are equal and these two sides are equal. This quadrilateral is a parallelogram. These two sides are parallel to each other, and these two sides are parallel to each other. This one right here, this side is parallel to this side, but these two sides are not parallel to each other. This is a trapezoid. Here we have a square. All 4 sides are equal and all angles are 90-degree angles. This here is a rectangle. Opposite sides are equal and parallel to each other, and all 4 angles are right angles. This is a rectangle. And here we have a rhombus. What happens here is all 4 sides are equal, but not all angles are equal. Only opposite angles are congruent to each other. This angle is equal to this one and this in measurement, and this angle is equal to this one in measurement. This is a rhombus, and this one is not a regular polygon. The only regular polygon that we have here is the square. All the other ones are quadrilaterals, but they're not regular polygons. Okay, so now we're gonna work some examples, okay? The question here is find the value for angle X. So there is your angle X. There is a few things we know about this figure. We know that from here all the way to here, we have 180 degrees. So what would be this little angle right here? So that's gonna be 180 minus 131. So that would be, that becomes a 7. So that would be 49 degrees. This is 49. And then we know that this angle right here and this angle right here, they're vertical angles. They're equal. These two angles are congruent, which means the same measurement, equal measurements. So that's 38 degrees. So we have the measurement of two angles and we're missing one. So what does that mean? That means that when we add these three angles together, we have 180 degrees. So if we subtract 180 minus the sum of these two, that would give us this angle. So let's add 49 plus 38. That is 87 degrees. So we're going to subtract 180 minus 87 degrees, and that is 93 degrees. So that's what this angle is, 93 degrees, and these two angles are vertical angles. So, and vertical angles are congruent, which means that x equals 93 degrees. So we found the measurement of x, which is what we were asked. So for B, we're doing the same thing. We're finding the measurement of angle X, and we're going to apply the things that we know. We know that this angle is 35 degrees. We know that these two are congruent because they're vertical angles. So this angle right here is also 30 degrees. And now we need to find this angle. So how do we find it? We use the knowledge that the sum of these three angles again is 180. So we have 31 plus 30 equals 65 degrees. So the remaining angle is 180 degrees minus 65 degrees. That's going to be 115. So this one is this angle right here is 115 degrees. Now from here all the way to here, this whole thing is a straight angle. You can see it's a straight line. So from here all the way to here is 180. So we will do 180 minus 115. Well, 180 minus 115 is going to be 65. You can see it right here. 65 plus 115 is 180. So 180 minus 115 is going to be 65. So the missing angle is 65 degrees. Then we have problem number 2. It says that the following figures are similar trapezoids. Trapezoids, remember, this is a quadrilateral with two sides parallel to each other. But what they're telling us here is that they're similar. That means same shape, but different size. They are proportional to each other. So corresponding sides are proportional. So we do know that 9 is to 15 as x is to 10, because this side is corresponding to this side and this side is corresponding to this side. So we can establish our proportion as 9 to 15 is equal, because we're establishing the proportion as x it is to 10, as x it is to 10. So this is a very simple type of algebraic problem because we have established our proportion. So we can go ahead and cross multiply to solve. 9 times 10 is 90 and 15 times x is 15x. Then divide both sides by 15, and we obtain that x is equal to 6, because 90 divided by 15 is 6. So we know that x is equal to 6. So they asked us to find x and y. We already found x. Now we need to find y. And we can use the same kind of proportion between the same sides. 15 is to 9 as y is to 6. 15 is to 9 as y is to 6. What are we going to do? We are going to cross multiply. So you have 6 times 15, which is 90, and then 9y. So we're going to divide both sides by 9. We can continue here. We have 90 equals 9y, so we're going to divide both sides by 9, and we get that y is equal to 10. This gave us the other value they were asking for. So x equals to 6 in the smaller figure and y equals to 10 in the bigger one. So we used proportions to find the two values that we were missing. Let's look at number 3. It says find all the missing angles. This problem we're going to do in class on Monday. We will do it together because it is a problem that is going to include a lot of the concepts that we're going to talk about in class on Monday. Let's look at number 4. This one, we have just talked about the concept on determining the sum of the measures of the angles of a dodecagon. What is a dodecagon? We didn't talk about that, but I'm going to tell you what it is. A dodecagon is a 12-sided polygon. 12-sided polygon. So how do we find the sum of the measures of the interior angles? We're going to multiply 12 minus 2 because that's the number of sides minus 2 times 180. So that's going to be 10 times 180, which is equal to 1,800 degrees. And then we are going to go to number 5 that it says, what is the measure of one of the interior angles of a regular pentagon? Remember, regular means that all angles are equal. So we'll find how much is the sum of all the sides. So a pentagon is equal to 5 sides. So the sum will be 5 minus 3, 5 minus 2, I'm sorry, the formula is 5 minus 2. I was thinking that 5 minus 2 is equal to 3. 5 minus 2 times 180. So that means 3 times 180, which means 540 degrees. So this is the sum of the angles, of the interior angles. Of the pentagon. But the question is, what is the measure of one of the interior angles of a regular pentagon? Since it is a regular pentagon, that means all the angles are the same. So we're going to take 540, which is the total, divided by 5, which is how many? 540 divided by 5 is 108 degrees. So each one of the 5 interior angles of the regular pentagon is 108 degrees.